the within the group, so inside the group itself, and then between the group, right? So there are two variances that you need to settle first before you can proceed with ANOVA test. Okay, so we already did the for the SPSS. So today we are going to learn more about ANOVA and also how can we do the hypothesis test. Okay, I really hope that you still have your patience and also energy, all right, to hear my lecture this late afternoon, right? So hypothesis, okay, the first thing, remember, the first step you need to do is to write the assumption. Why do you need to use ANOVA? That one is the first step. And then the second step, you need to write your hypothesis, all right? So you need to write your H naught and also your HA. So a little bit different from what we had before. Right, before when we have t-test, remember the independent t-test. So we have HO, mu1 is equal to mu2 because we only have two samples or two groups that we want to compare. But for the ANOVA, we have more than two groups. We may have three groups, four groups, 10 groups, and so on, right? So you need to write this way, just like what we have for the independent t-test before, but you need to expand it, all right, based on how many groups do you have, how many samples. So let's say you have three groups, so it means that you need to write mu1 is equal to mu2 is equal to mu3, all right? So this is just in case you have three groups to be compared. And then before in independent t-test, all right, we have HA where we have mu1, let's say, not equal sign greater than or less than mu2, right? So that one is for the independent t-test. But for ANOVA, it's very hard for us to write something like, HA mu1 not equal something like this, mu2 not equal mu3, right? To write the equation is not that easy when we have different kind of symbols, right? So therefore, the best way to write our HA is just to write this sentence, okay, where you need to write at least one population mean, okay, or at least one population mean is different from another, all right? So that's how you write your HA for ANOVA. So instead of writing an equation, you need to write a sentence. Okay, so I really hope everybody can understand that, right? And then instead of using t-test, remember we learned something about, Z table at the back, 191, something like that. And then we also have table for t-test. Okay, if you go back to page, let me see, okay, is on page 212, right? Sorry. Yeah, 212 and 213. So you have a different table, okay? This table is called as F test table, F distribution table. So this one only can be used when you are using ANOVA. So for ANOVA, you need to have a special table, statistical table, which is called as F table, right? So, but in our case, so we are not using the table, but we are going to get all the information from SPSS, right? So the F distribution is continuous and skewed to the right. Okay. So instead of like normal table, we have something balanced in the middle. The mean divide, left and right side. So where the left and right side have equal area and they are balanced. But for the F distribution, it is skewed to the right. So the shape will be something like this, right? So yeah. Saya yang salah. Let me check. Nanti to confirm, reconfirm. Oh, salah. Right skewed. So it is, yeah, right skewed. start left skewed, right? So skewed to the right. So the shape should be like this, right? Okay. So this is how it looks like. So what I can actually see, okay, the shape of the F distribution is like half of this normal table, a normal distribution. So we only take, this part right here, okay, this one, right? So, right, so for the Z, we only have information for alpha, right, in order to use the table. And then for the t-test, we need information for alpha and also df. But for the F distribution, we have alpha, df1, and df2, where df1 is actually for the within the group, okay, the variation within the group, and then also df2 is actually for between the group variation. So we have two types of degree of freedom, right? And then the units in F distribution will be non-negative, okay? Like normal, we have the negative side and we have positive, negative and positive. But since F distribution only the right side of the normal table, okay? So it only have positive values, right? Okay, this is how it looks like. Okay, it start from here, it's good. And then if we have more and more number of respondents, number of samples, so the F distribution will tend to be normal. Okay, so from the skewed, if we add more and more people, in our survey, in our study, for example, so it will be skewed to normal. So it becomes a normal distribution, right? So this is values that we need, okay? So remember I said one of the important things that we need to obtain for this chapter is to get something which is called as Anova table, right? Right. So and then I also mentioned before, right, where we need to do two different steps, procedures. The first thing, we need to do the living test in order to check the equality of variances. When you sometimes maybe you say, what is actually variances that Dr. Ati keeps saying, variances, variances. Variances is difference. You also can, what is actually the difference between the two groups and so on. Right? So this is the four steps that we need to do. First, we need to construct all the information in the ANOVA table, and then we need to also check the equality of, before this one, actually we need to check the equality of variance first, and then only we can check the equality of means. And then test the null hypothesis using the F statistics obtained in the ANOVA table, and then we need to make conclusion. Okay. The next one that I would like to mention is something which is called as post hoc test, right? So you will be wondering, alamak, what is this? Okay, we have living test, we have ANOVA test, and also the next one we have post hoc test, right? So post hoc test, I will explain it to you when we do the example. But in our case, in for my students, okay, I only use two type of tests. Post hoc test ni ada macam-macam, different types, okay. But for my student, I will use two key on thoroughly, right? Akila, Akila tertekan suara Akila, semua orang dengar. Akila, Akila, please make sure you mute yourself. So otherwise, everybody knows what's happening to you now. Nanti rahsia sampai terbongkar, Akila. Dia tengah jalan-jalan tu. Okay, so we already entered this exercise 3, all the data in our SPSS, okay, and then we got this output, all right. So now today we are going to, I'm going to explain what do you have from your SPSS, right? So the first thing that you will get is actually descriptive table. When you click the descriptive table, right? So you have this 95%, this one by default, SPSS default. Okay, if you would like to change to 90%, 93%, 90, 99%, for example, so you need to change the percent of your significance level, right, or confidence interval. Right, so we have 4 treatments, okay, in our question. So for the each treatment, so this is the mean for each treatment and the number of n, right? So we have the standard deviation, standard error. So what does it mean by standard error? Remember, standard error is actually standard deviation divided by n, right? So you get this number when you divide this one by square root of 5. For example, you will get your standard error. And then for the confidence level, so I think everybody knows already that your confidence interval should be presented by lower bound and upper bound, right? So for example, so we have this lower bound 8.17, upper bound is 15.8. So what does it mean? So it means that the confidence interval for treatment 1, the mean is 12 at the center. So the lower bound is 8. All right, I just take the number in front, okay, and then 15. So that's what it means by confidence interval. So 95%. So what does it mean? Because we believe that 95% that the respondents, okay, in treatment 1, those in treatment 1, okay, let's say they have a score between 8 and 15. Okay, 95% of them. So that's what it means by the confidence interval. Right? Okay, so and then the minimum. So the minimum data for treatment 1 is 8, the maximum is 15. So if we ask what is the value of our range, R, so it's going to be minimum and maximum minus minimum. So 15 minus 8 will be 7. So we can see that the range from lowest to highest in treatment 1 is 7. Okay. All right, so now is our first step to do the living test, right? Before we can further our analysis. So the first thing that we need to make sure that the 4 groups, they are not different, okay? They are almost similar. Okay, so for example, so in this case, all right, so the purpose of the living test is to check the equality, the differences or the equality of variances. Homogeneity means equal ataupun sama. Right, so in this case, so we do the first step, all right? The first step is to check equality of variance, right? So we need to use living test. So that's the first step that you need to do, right? Okay, so people, this one will be on page berapa ya? One one four. Is that right? Is it page 114? Okay. Right. So okay, thank you, Anong, for always being so supportive. Right? Thank you, Anong. Right. So the step number 1 and step number 2. okay, we need to write our hypothesis. So we want to check whether the variance, the difference, is there any differences between the four groups, okay? Okay, when I said variance, okay, variance, the simple is sigma. So that's we do 1, sigma squared 2, sigma squared 3, and sigma squared 4, right? And then for the HA, one of the variances is different or not equal, right? You can, in a few ways, eh? So that's the second step, right? So let's continue. Okay, the third step is to find what is the alpha, 0.05, and then what is df1, okay, and then df2, okay. So df1 and df2, how can we get the answer? So you need to look at the Anova table later on, okay? So, but you can see also here, okay? So this is what we want to look at, right? So we don't want to look at all this, right? So we are based only on the median. So you can see the df here is 3 and 18, okay? 3 and 18, right? Right, and then we need to find the sigval from the SPSS. So the sigval will be this one, 0.101. Okay, is everybody okay? Okay, thank you. Okay, thank you, Zian. Thank you, Tika. All right, thank you, Alia. All right. Okay, so this is the third step. And then our fourth step, okay, the last step, right? So the step number 4, reject H naught, okay, if alpha is less than 0.0, well, sorry, the sigval, okay? Sigval is less than 0.05. So is, okay, our sigval is 0.101. Is it less than 0.05? Yes or no? What's the answer? Yes or no? Okay, the answer is no, right? So no, because obviously 0.101 is greater than 0.05. So since the answer is no, we cannot reject the H naught. Therefore, we need to accept H naught. Okay, when I say accept H naught, okay, we need to go back to our hypothesis. So we accept this one. So this one we accept, this statement right here. Okay, so what can we conclude? Are the variances equal or not? Can somebody tell me? Okay, we accept our H naught. So what can we conclude? What can we say? The variances equal or not?
Equal.
Yes. Okay. So because H naught means variance daripada sample 1, sample 2, sample 3, sample 4 equals same. Alright. So therefore, we need to write, so we can conclude that the variances from the 4 samples are equal. Okay. Remember, I told you that in order to do this ANOVA test, one of the requirements, one of the assumptions that we need to fulfill is to make sure that the four samples or whatever samples that we want to compare, they are equal. They are not different. Okay. So remember, if they are totally they have a very big gap, then it means that the variance are not equal, then we cannot actually proceed with ANOVA. So in this case, in our case, because they have equal variance, so it means that we can proceed to ANOVA. Proceed to ANOVA. Right? Because it means, it's fair to compare them because they have equal variances. Okay, I stop here for 2 minutes, all right, before we proceed to ANOVA test. Okay, that one I think you can have apa actually on page 115, okay, you can copy this one down. Actually, this mean and then also standard deviation, but alpha, df, and mean, okay? So you can copy this one, not sum of x and sum of x squared. You don't have information here, right? So instead you can change it to, the standard deviation and also standard error. Okay, I give you like 3 minutes, okay, for you to complete whatever information in table 115, okay, for treatment 1, treatment 2, and treatment 5, okay. So by using this descriptive table, okay, can you please do this one? Okay, people, if I'm going too fast, okay, please let me know, right? I'm trying to go very slow in order for you to understand the concept, the steps, and so on. Because ANOVA question will appear in your final exam, confirm, okay? So 100%. So that's the reason you need to understand the steps and also the concept behind it. And also before I forget, sebenarnya, okay, please don't put your assignment in the yellow box in front of my office. Sebenarnya that box is actually for sampah, for trash. So I'm afraid that, the cleaner will thought that one is sampah. So she will take it and throw it away. But I already asked, my colleagues to check for you and collect from that box and put inside my office, right? So if possible, just put in a plastic bag and then, put it at the knob, hang it, okay? Hang the plastic bag at my doorknob, right? Rather than put in that box. Okay, let's continue. Okay, we already did the living test, so it seems that our living test is good. The variances are equal. Now we can proceed with our ANOVA test, okay? So one of the things that you need to understand is the ANOVA table. So ANOVA table is one of the objectives that you need to achieve, you need to understand in this chapter, right? So this ANOVA table, you got it, from SPSS. But before your seniors, they need to calculate it manually. During that time, like a few years back, I don't ask them to get, straight away from the SPSS. They need to calculate it manually. Why? Because I want my students to understand every figure that appeared in the SPSS output, not just simply look at it without understanding how the number comes from, right? Okay, so let's have a look. All right. So the first thing, okay, we look at this degree of freedom column, right? So remember we have this one is actually our variance, okay, variations. So we have between group and also within the group, right? So the best part to calculate first is this one, number one, and also number two, right? So I already showed it to you actually before. So total, so you know when it comes to degree of freedom, it's always n minus 1, right? So n minus 1 in this case, so we have altogether how many? So how many, sorry, what is our n, right? So what is our n? So n is actually the number, n stands for, the letter n comes from word number, okay, number. Okay, bilangan. So the number of people or respondents, involved in this study, all right? So we have the total is 22 people, all right? So this in this ANOVA table, so n minus 1 will be 22 minus 1. So this number will be 21, right? So that's the reason you get it 21 here, right? So I would like you to do it manually, all right? Write it manually on page 115. Don't just copy straight away from the ANOVA from SPSS, right? We need to learn, right? So how do I get 21 people? And minus 1. And the total is 22 minus 1. That's the reason we get 21. All right. And then the next one we need to calculate is the easiest one is this one, number 2. Right. So number 2 is K minus 1. As I told you, K is group of kumpulan. Right. So we have 4 treatments. So it means 4 minus 1. So that's the reason we get 3. Right. So that's how we get number 3 here. Right, now, in order to get this number, right, this number within treatment, so it just get 21 minus 3, so we get it 18. Or 3 minus plus 18, the total is 21. Right, next one is sum of squares. Right, sum of squares is actually you get all this number right here using the formula, right? So the formula, let me see, ada tak formula dia kat sini? I just want to share it with you. Oh, in our book, sorry. Okay, so you can see the formula in the book on page 114. So you can see SS total is actually the easiest way. So SST, so the SS total, you can see that's the formula that you can find, and then SS total. So, but right, in for this part, okay, you can just take it from the SPSS. So just write 68, 94. So in order to get the total, 68 plus 94, 12, okay? So 162, right? Okay. This one you got it from here. But for the MS, how do we get from the MS? Okay, for the MS treatment or between, okay, treatment is this number, okay, 68 divided by 3, right? So that's how you get 22.667, right? It's actually this number divided by 3, right? Or from here, the ANOVA table, 68. Okay, dah macam haru biru dah pula banyak sangat. Okay, let me make it clear lah kat sini. Okay. Yang fresh one lah. So at least you all can see clearer. Okay, how do I get this 2.667? This number divide by 3, so it's equal to this one. 94 divided by 18 is equal to this one. So what this one no need, right? We don't have to divide that one because that one is for total. Right. So what I want you to do, people, can you just take your phone or your calculator and try to divide this number? Is it true? 68 divided by 3, do you get 2.667? Try it. Jangan malas-malas. Right? Okay, thank you, Joey. Okay, thank you, Idora. Right. And then that's how you get the number for the mean square, right? To find the mean square is the sum of some squares divided by TF, right? And then how do I get this number, DF? Right, this number you get from 22 points ni macam bahagi, right? This one lah bahagi, alright, divide. 22.667 divided by 5.222. So you will get this number, 4.340. Can you please try and get it? Cuba. Okay, betul. Alright. Okay, good. So the significant value, you got it from SPSS, alright? So there is a way how to get this number, alright? So, okay, that's all. In order for you to understand the ANOVA table, so all right. Let me, so ANOVA. So let's do now. We want to do the ANOVA test. Okay. ANOVA test, all right. So step number 1, okay. So we just say we want to compare 4 groups, right? Sorry, 4 independent groups. So we need to use ANOVA, right? So that's the first step, right? Okay, this one you can do it on page 116, all right? To answer page 116. Okay, using the 5% significance level, people, untuk yang page ni, I would like you to divide this page into 2 parts. Alright, satu untuk ANOVA dan lagi satu untuk post hoc test. Okay, can you just divide? Don't use all of them for ANOVA. Okay, so to compare the 4 independent groups, then we need to use ANOVA to step number 1. And then we have step number 2. We need to write HO and also HA. So we have 4 groups. Mu1 is equal to mu2 is equal to mu3 is equal to mu4. And then for HA, one of the means, okay, one of the means is different, right? Okay. Right, next step number 3. Push. Okay. Mak, tersilap ke? Tersilap lah you all. Okay, set. Buat dia kat tempat lain pula. Okay. And then step number 3. Our alpha is 0.05 based on the questions. So df1 just now kita dah dapat df2 is equal to 1. So remember we got here the df is 3 and 18, right? So you just write the df 3 and 18. So our sigma, okay, sigma is equal to, just get this number right here, 0.018, okay, 0.018, right? So that's our sigma. So and then number 4, okay, in this case, we don't have 1 or 2 tail. Remember, we only have all the right side. So no more 1 or 2 tail. All right. So step number 4, reject, okay, reject H naught if sigma less than alpha 0.05. Okay. Is 0.018 less than 0.05? Yes or no? Any answer? Yes, all right. So, yes, the answer. Then, if yes, then we need, therefore, plus, all right, reject H naught. Okay. Okay, people, when we say we reject H naught, it means what? We accept HA. That's what it means, okay? Reject H naught, we accept HA. Okay, so what does it mean? Right, we need to go back and look at uh, our hypothesis. Okay, when we accept HA, so it means, okay, we accept this one is correct and our H naught is not correct. So what does it mean? So it means that, okay, conclusion. So one of the means is different. Right. In order to know who is different, proceed to post hoc test. So that's what we need to do. We already know that one of the means is different, so we need to proceed. We need to find out who is different among them, among these 4 treatment, who is actually different, right? So that's what we need to do, right? All right, I stop here for 3 minutes for you to digest, to understand, and then also to write down the answer for this ANOVA test, right? Okay, 3 minutes. Okay? Is everybody okay semua? Right, so let's continue. We already decided that we need to proceed to post-hoc test because we need to investigate among the 4 treatments who actually different from one another. All right. So and then this is our post-hoc test, right? So how do we get this one? Remember, we tick or we tick in the options button, right? And then we tick on the post-hoc test, and then we choose what two key, and also we can also choose Bonferroni. Actually, the results will be the same. Okay, it won't give you much difference. All right. So how can we detect who is different? So let's have this table right here. Okay. So people, I suggest, all right, I suggest what you can do, if possible, you try again this, doing this question, and then once you get the output, you print it out, okay, and then once you get this print out, so you can cut it and then glue it to your book ataupun somewhere lah, or staple it to your book. So at least you know this is all the figures, all the tables, all the outputs that you obtain from your SPSS. Okay, listen carefully, right? So how can we detect who is actually different? So what you need to do, you need to refer to this column, the significant column, right? So whatever column less than alpha, in our case, our alpha is 0.05. So I want you to highlight it or you tick it, okay, like this, okay? This one less than 0.05, less, okay? The rest, no, okay? So whichever, whichever has value less than 0.05, those are actually different. Okay, so for example, what we can say, this one is treatment 1, we take this one, treatment 2, so it means that treatment 1 and treatment 2 different. Treatment 1 and treatment 3 also different. Treatment 3 and treatment 1 is different. Okay, so whatever we tick, okay, this is the mean, this is the partner, right? So whatever we tick or we highlight just now, they have differences. So that's what it means. Understand? So kalau you tengok kat sini, the mean difference is significant at the 0.05 level. Okay. And then the next table that we can look at is actually this one. I love this one, this table. Who is different? So we can easily detect by homogeneous mean, similar. So this two key test, okay, help us. It clusters or it group the one who is similar together, right? So in this case, this test is it group treatment one and treatment 4. It says they are similar, they can be together. But the second group, treatment 4, treatment 3, and treatment 2, they are almost equal. So they can be grouped together, right? That's what it means. So if you can see, the difference is also not that much. 15, 16, 17, almost similar. And this one, 12 and 15, almost similar. But if we look at treatment 1 and treatment 2, very big gap. Because one is 12, the other one is 17. Right? The difference is quite big. And then another best thing that we can produce is something that we call it as means plot. Okay, so the means plot is actually plotting all the means for each treatment. So we can see who is actually different from another. So what we can see is obvious. Treatment number 1 and treatment number 4, they are very far. So we can conclude that treatment 1 and treatment 4 is actually very, very different. Okay, but treatment 2, treatment 4, 3 and 4, they are not that different. Okay, that's why they are very close together, the location of the mean. But treatment 1 and treatment number 2 is very far away. Okay, for example. So that's how we can conclude. So it supports, it says that treatment 1 and 4 can be together. Okay. Treatment 1 and 4 can be together, but treatment 1 and 2 is obvious, very different. Okay. Understand? Okay. Just to let you know, okay, benda ni akan keluar dalam final exam. So you need to understand how to read the Miss plot and how to read the 2P post hoc test table, right? All right, so that's the end actually for question number exercise 3, all right? So let's take a break, okay? Maybe only for a while, okay? And then I would like you to continue with exercise exercise 15, all right? So exercise 15 on page 174. Betul ke? Ini page number? I'm not sure whether I'm using the right book or not. Is it correct? Okay, I would like you to answer this question, which is number 15. Right, a study was conducted to investigate the influence of college major on the starting salary of local university graduates. Okay, 21 recent graduates who were majored in engineering, liberal arts, and also business admin, were interviewed on their first job. The results obtained for these respondents are shown in the following table, right? So what you need to do, people, you need to put all the data in SPSS, all right? I really hope that you still remember how to enter the data. And then you need to complete the Anova table. Okay, so try to get the information, right? And then fill that one in and then answer question A, B, and also C. Okay, can you please do it now? Okay, maybe you can write